Come on students, now we'll start the next problem, problem number 13. So 12 problems so far we have completed. Now see the 13th problem. Find out the fallacy, if any, in the following statements. Fallacy means, is the statement given is correct or wrong? We have to just give the conclusion whether the given statement is true or false. So 5 different cases are given. In each case we have to say whether this statement is true or false. What is the first statement? Finding the fallacy in the given statement. First statement, mean is equal to 4 and standard deviation is equal to root 5. Whether this statement mean 4 and standard deviation root 5, is it correct or not? We have to prove it. So how to prove? Mean, the formula for mean in binomial distribution is NP. The formula for mean is NP is equal to 4 given. Standard deviation is root 5. So I already discussed to you in the previous video that variance is the square of standard deviation, or standard deviation is equal to under root variance. Variance को root कर दो standard deviation आ गया, या standard deviation को square कर दिया तो variance आता. So here standard deviation is given root 5. Now I need variance. Standard deviation is equal to root 5. That means variance is equal to 5. Variance is equal to 5. Square कर देंगे. ये root 5 को अगर square कर देंगे तो root चला जाएगा. If you square root 5, the square root will go away. So variance is equal to 5. In other words, we can say variance is equal to 5. अगर standard deviation मालूम करना है तो variance को root कर दो. तो root 5 will be standard deviation. Got it? So variance is equal to 5. What is the formula for variance? Variance formula is NPQ is equal to 5. The formula for variance is NPQ is equal to 5. Now NPQ is equal to 5. NP means mean. The formula for mean is NP. Here it is given. Mean is equal to NP is equal to 4. So in place of NP I am writing 4. So 4Q is equal to 5. Now Q is equal to 5 divided by 4. Yeah, multiply hai, so it will become divide. So 5 divided by 4, 1.25. So we got the value of Q 1.25. The statement is false, not true, not correct. So the statement mean is equal to 4, standard deviation is equal to root 5. This statement is false. That is not correct. Why not correct? Because P and Q are the probabilities. P is the probability of success, Q is the probability of failure, and the maximum value of the probability is 1. The probability will never exceed 1. कभी भी probability का value 1 से बड़ा नहीं होता. यहाँ पर 1 से बड़ा हो गया. Q is equal to 1.25. How is it possible? It is not at all possible. तो इसके लिए the given statement mean is equal to 4, standard deviation root 5 is false, wrong. The given statement is wrong because the value of Q should not exceed 1. 1 से बढ़ना नहीं, maximum 1 आ सकता, या 1 से below आ सकता, लेकिन 1 से बढ़ना नहीं. बढ़ गया तो समझना ये statement wrong. Next, mean is equal to 7 and standard deviation is equal to root 8. Now we'll check. Mean, the formula for mean is NP. NP is 7. And NPQ, variance. NPQ is nothing but variance. Variance is the square of standard deviation. Variance is the square of standard deviation. ये standard deviation को square करे तो variance होता. तो 8 under root 8 को square करे तो root चला जाता. If you square this under root, the root will go away. So it will remain 8. So variance is equal to 8. NPQ is equal to 8. So NP, in place of NP I am writing 7. 7Q is equal to 8. Q is equal to 8 divided by 7. 1.14. Again the statement is wrong because the value of Q is exceeding 1. Same just like the first statement. The given statement is false because the value of Q is exceeding 1. Now see it. Mean is equal to 4, standard deviation is equal to 3. So variance is equal to square of standard deviation. Variance means the square of standard deviation. तो standard deviation 3 है, तो 3 को square कर दिया तो 9 हो गया. So variance is nothing but 9. NPQ is equal to 9. NP is how much? 4. Mean is NP. NP is equal to 4. So NPQ is equal to 9. NP के place पर 4 लेंगे. 4Q is equal to 9. Q is equal to 9 by 4, 2.25. Again it is wrong. This statement mean 4, standard deviation 3 is wrong. because the value of q is exceeding 1. Here, mean is equal to 4, variance is equal to 3. Now we'll check. Mean formula is NP. NP is equal to 4 and NPQ is equal to 3. Variance is 3. Right? So NPQ is equal to 3. NP is 4. 4Q is equal to 3. Q is equal to 3 by 4, 0.75. So Q we got 0.75 and P is equal to 1 minus Q. 1 minus 0.75, 0.25. Since the values of P and Q are less than 1, so the statement is true. The first statement wrong, second statement wrong, third statement wrong. Now fourth statement is true because the value of P and Q are less than 1. It is possible. It is correct. Last one. Mean is equal to NP is equal to 10. It is given in the problem. Mean is equal to 10. Standard deviation is 4. Therefore, variance is equal to 16. Square of standard deviation. ये standard deviation को square कर देंगे. 4 4 is 16. तो NPQ is equal to 16. NP 10. 10Q is equal to 16. Q is equal to 16 by 10. 1 by 1.6. Q is equal to 1.6. Again, the given statement is false. Wrong. Because the value of Q is exceeding 1. That's it. So this is the problem number 13. Where it is simply asking you to prove whether the statement is true or false. We have seen. Now we'll come to the next problem, 14th. Is there any consistency in the statement? The given statement again, is it consistent or inconsistent? That we have to explain. The mean of a binomial distribution is 40 and the standard deviation is 4, just like the previous problem. One statement is given, mean of a binomial distribution is 40 and standard deviation is 4. This is the statement. Now tell me whether this statement is consistent or inconsistent. अगर P और Q का वैल्यू 1 से कम आ गया तो कंसिस्टेंट है. अगर एक भी वैल्यू P, Q का वैल्यू 1 से एक्सीड अगर हो गया तो the statement is inconsistent. If no inconsistency is found, what will be the values of P, Q and N? अगर inconsistency नहीं है, then what is the value of P, Q and N? We'll calculate, no problem at all. Mean is equal to NP is equal to 40. Given in the problem, standard deviation NPQ root is equal to 4. The formula for standard deviation is NPQ root, that is given as 4. Therefore, variance is equal to NPQ is equal to 16. Square कर दो 4 को 16. So variance is equal to 16. NPQ is equal to 16. NP, how much is NP? 40. 40Q is equal to 16. Q is equal to 16 by 40. 0.4. Q is equal to 0.4. चलिए, we got less than 1. So P is equal to 1 minus Q. 1 minus 0.4. 0.6. So we got the value of P 0.6. Q 0.4. The given statement is consistent. Inconsistency नहीं है. There is no inconsistency involved. The given statement that mean is 40, standard deviation is 4 is correct, consistent. There is no inconsistency in the problem since P and Q are less than 1. NP is equal to 40. So N, P already we got it 0.6. P के जगह पे 0.6 लेंगे. N into 0.6 is equal to 40. N is equal to 40 divided by 0.6. So N is equal to 67. So the binomial distribution consists of N is 67. P is 0.6, Q is 0.4. That's it. Finished. Next to problem 15th one. The mean of a binomial distribution is 20 and the standard deviation is 4. So mean given, standard deviation. Calculate NPQ, exactly similar to the previous problem. Mean is NP, that is 20. Standard deviation NPQ root is equal to 4. So variance NPQ is equal to 4 4 is 16. So NPQ 16. And 20, NP is nothing but 20. So 20Q is equal to 16. Q is equal to 16 by 20, 0.8. So we got the value of Q, 0.8. P is 1 minus Q, 1 minus 0.8, 0.2. So we got the value of P, 0.2, Q, 0.8. NP is equal to 20. So N into P, P how much? 0.2. N into 0.2 is equal to 20. N is equal to 20 by 0.2, 100. Therefore, binomial distribution consists of N 100, P 0.2, Q 0.8. That's all. 15th problem completed. Now 16th one. A binomial distribution has N is equal to 20 and P is equal to 0.3. N is equal to 20, P is equal to 0.3. Find the mean and variance of this distribution. You have to calculate the mean and variance. Here mean and variance you have to find out. So Q is equal to 1 minus P. P is 0.3. So 1 minus 0.3 is 0.7. So Q is equal to 0.7. So mean is equal to NP. N is 20 and P is 0.3. So 20 into 0.3 is 6. So mean का value आ गया 6. Now variance NPQ. N is 20, P is 0.3 and Q is 0.7. Multiply 4.2 is the variance. So we have completed 16 problems on binomial distribution. Starting problems we have calculated all probabilities. And now we have calculated the mean, variance and standard deviation. Now we'll start the next problem, problem number 17. See the 17th problem carefully. Fit a binomial distribution to the following data. X values are given 0, 1, 2, 3, 4 and frequencies are given 28, 62, 46, 10, 4. This is a new type of problem. Here it is asking you to prepare a theoretical frequency distribution. Theoretical frequency distribution table by applying the law of binomial. Right? So fitting a binomial distribution table. So first of all, what data is given in the problem? X values are given 0, 1, 2, 3, 4. Frequencies are given 28, 62, 46, 10, 4. We calculate the mean. Arithmetic mean. Everybody know how to calculate arithmetic mean? Simple. Summation of x by n. It's a discrete series. So mean का formula है summation of x by n. So we need a column fx, f into x. Multiply 0 into 28, 0, 1 into 62, 2 into 46, 3 into 10, 4 4s are 16. Total summation of x 200 and n total of frequency 150. Now mean का arithmetic mean का formula है summation of x by n. So 200 by 150, 1.33. 1.33 is the mean value. And according to binomial probability law, the mean formula is NP. The formula for mean is NP according to binomial law. So according to binomial law, mean is NP. And we got the mean value 1.33. In other words, we can say NP is equal to 1.33. Now N. What is the highest value in X? The highest value of X is 4. Highest value of X is 4. So N is equal to 4. Now NP is equal to 1.33. N already we got 4. So in place of N I am writing 4P is equal to 1.33. P is equal to 1.33 divided by 4. You are getting 0.33333 like this. This is nothing but 1 by 3. 0.333 is nothing but 1 by 3. So we can write P is equal to 1 by 3. Once you get the P, easily you can calculate Q. Q is nothing but 1 minus P. So 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3. So we got the value of P, we got the value of Q and N. N is 4. That's all. The main parameters which are required for binomial distribution we are having N, P, Q. Now we can find out the probability of P of 0, P of 1 like that. According to binomial law, P of R is NCRP to the power of R, Q to the power of N minus R. Same formula. So P of R is equal to 4. N is nothing but 4. So 4CR 1 by 3. P is 1 by 3. 1 by 3 to the power of R. And Q is 2 by 3. 2 by 3 to the power of 4 minus R. This is the formula. Now we calculate P of 0, P of 1, P of 2, P of 3, P of 4. All the probabilities we need for X ka value 0, 1, 2, 3, 4. So P of 0, 4C0, 1 by 3 to the power of 1, 1 by 3 to the power of 0, 2 by 3 to the power of 4 minus 0. First we are calculating P of 0. So 4C0, 1 by 3 to the power of 0, 2 by 3 to the power of 4 minus 0. So 4C0 is 1, 1 by 3 to the power of 0 is 1. Now 2 by 3 to the power of 4, 4 minus 0 is 4. So 2 is multiplied 4 times, 2 into 2 into 2 into 2, 4 times, 16. 3 is multiplied 4 times, 3 3 is a 9, 9 9 is 81. So 16 by 81. So 16 by 81 is P of 0. Similarly, we calculate P of 1. 4C1, 1 by 3 to the power of 1, 2 by 3 to the power of 4 minus 1. So 4C1 is 4. 1 by 3 to the power of 1 is 1 by 3. Into 2 by 3 to the power of 4 minus 1 is 3. So now you can multiply 4 into 1 by 3 is 4 by 3. Into 2 is multiplied 3 times, 8. 3 is multiplied 3 times, 27. 8 fours are 32 by 81. So 32 by 81 is the P of 1. We got P of 0, 16 by 81, P of 1, 32 by 81. Now P of 3, P of 2, 4C2, 1 by 3 to the power of 2, 2 by 3 to the power of 4 minus 2. You simplify, you will get 24 by 81. Similarly, P of 3, substitute the values, you will get 8 by 81. P of 4, you will get 1 by 81. So we got the value of P of 0 to P of 4. All the values you got. Now we need expected frequency because we want to make theoretical frequency distribution. We don't require probability. Probability मालूम करने के बाद उसको expected frequency मालूम करना in this problem. So binomial distribution table. Expected frequency E of R, E stands for expected. Expected frequency of R is N into P of R. N, capital N is nothing but the total of frequency. The total of frequency already we got it 150. So in place of N we write down 150. P of R, R ke place pe 0, 1, 2, 3, 4 already we have calculated all. Now we'll make an expected binomial distribution table. This table is called binomial distribution table. X value 0, 1, 2, 3, 4. Expected frequency E of R, capital N into P of R, right? And last column frequency. Now P of 0, I will write down not P, I will write down E of 0. No, E of 0 is P of 0. Expected frequency of 0 is P of 0 into 150, correct? P of 0. How much is P of 0 here? 16 by 81. So 16 by 81 into 150, you will get 29.63. We'll round it off to 30. 29.63 is to round off करके मैं 30 because frequency will be in whole number 30. Then E of 1, expected frequency of 1. So P of 1 into 150. P of 1 is 32 by 81. 32 by 81 into 150, 59.26. Round off कर दो 59, right? उसी तरह E of 2 मालूम करना तो P of 2 into 150. P of 2 24 by 81 into 150, 44.44. I have taken 44. E of 3 is P of 3 into 150, 8 by 81. 8 by 81 into 150, 14.81, approximately equal to 15. Then E of 4, P of 4 into 150, 1 by 81 into 150, 1.85, rounded off to 2. The total of the expected frequency, you must get 150. The actual N is 150 and theoretical N is also, you should get 150. You must get 150, right? So this is the problem where we have prepared the theoretical frequency distribution according to binomial probability law. Binomial probability law बनाकर ये expected frequency distribution table बना. So how we have calculated? First we have calculated the mean. By using the mean we have calculated NPQ. N तो already दे दिया है 4. PQ we have calculated P and Q. Once you get NPQ, find out the P of R. P of R, R की जगह पे 0, 1, 2, 3, 4, P of 0, P of 1, P of 2, P of 3, P of 4. ये मालूम कर लिया expected frequency capital N into P of R. Multiply कर लो expected frequency table. That's it. So this is the problem number 17. Now we are in the last and final problem of binomial distribution. After this, we'll take up the next distribution called Poisson. The last, you see the last 18th problem. 5 fair coins were tossed 100 times. The small n is number of coins. How many coins we are throwing? 5 coins. How many times we are throwing? 100 times. So we can say capital N is 100 and small n is 5. Then from the following outcomes, calculate expected frequency. Number of heads up, 0. Observed frequency 2. Here the data is given observed frequency and we have to calculate the expected frequency according to binomial law. तो क्या करें 5 coins throw कर रहे हैं. First time, second time, third time, like that 100 times we are making these experiments. तो first time 5 coins throw करें, 0 head. 0 head का मतलब no coin is showing head. All the 5 coins are showing tails. So how many times this had happened? 2 times. So out of 100 times, 2 times we got 0 head, no head at all. All the 5 coins are showing tails. Then 1 head. Out of 5 coins, 1 coin is showing head, the remaining 4 coins are showing tail. So how many times this occurred? 10 times. 2 head, 3 tails occurred 24 times. 3 head and 2 tails 35 times. 4 head and only 1 tail. This happened 18 times. And all the 5 heads, all the 5 coins are showing head. This occurred for 8. This is the observed data. This is the actual data. Now we have to apply binomial distribution and find out the expected frequencies. Observed frequencies are given. By using that, we have to calculate the expected. Now see here, when a coin is thrown, the probability of getting head is 1 by 2 and the probability of getting tail up is 1 by 2. Head या tail आने के chances 1 by 2, 1 by 2. Therefore, P is equal to 1 by 2, Q is equal to 1 by 2 and small n is equal to 5. So all the values are given. No need to calculate the mean. According to binomial law, probability of R success is P of R, NCR, P to the power of R, Q to the power of N minus R. Then 5CR, half to the power of R, half to the power of 5 minus R. Now we calculate P of 0, P of 1, P of 2, P of 3, P of 4, P of 5. All the 5. So 5C0, half to the power of 0, half to the power of 5 minus 0. So 5 minus 0 is 5. So when bases are same, powers can be added. Or 5C0 you will get 1. Half to the power of 0 also equal to 1. Half to the power of 5 you will get 1 by 32. 1 by 5 to the power of 5. 1 by 2, not 1 by 5. 1 by 2 to the power of 5. 1 by 2 to the power of 5 is equal to 1 by 32. So we got P of 0, 1 by 32. P of 1, 5C1, half to the power of 1, half to the power of 5 minus 1. So 5C1 you will get 5. When bases are same, power can be added. Here power is 1, here power is 4. So 1 plus 4 is 5. So half to the power of 5, already we know 1 by 32. Half to the power of 5 is 1 by 32. So 5 into 1 by 32, 5 by 32. P of 2, 5C2, half to the power of 2, half to the power of 5 minus 2. So 5C2, you calculate, you will get 10. 5 factorial divided by 2 factorial into 5 minus 2 factorial. You will get 10. Into half to the power of 5, so 10 by 32. Similarly, P of 3, 10 by 32. P of 4, 5 by 32. P of 5, 1 by 32. We got all P of 0, P of 1, P of 2, P of 3, up to P of 5. Expected frequency E of R. Expected frequency E of R. Capital N into P of R. Capital N is 100. Problem is that 100 times we are making the experiment. 100 into P of R. So P, number of heads up, 0, 1, 2, 3, 4, 5. Expected frequency E of R, capital N into P of R. 100 into P of R. So E of 0 is equal to 100 into P of 0. 100 into P of 0, already we got it 1 by 32. So 100 divided by 32, 3.2125. I have rounded off to 3. 0.25 छोड़ दिया, fraction, rounded off to 3. E of 1 is equal to 100 into P of 1. 100 into 5 by 32. 5 by 32 is here. So 500 by 32, 15.625, rounded off to 16. Then E of 2, 100 into P of 2, 100 into 10 by 32, 31.25, 31. Then E of 3, 100 into P of 3, 100 into 10 by 32, 31.25, 31. Then E of 4, 100 into P of 4, 100 into 5 by 32, 15.625, I have taken 15. Here I have taken 16, here I have taken 15 because I want to round it off to 100. E of 4, 100 into P of 4, we have taken. E of 5, 100 into P of 5, 100 into 1 by 32, 3.125, I have taken 4. Take the total, you must get 100. These two problems are important. Normally, they will ask an examination regarding fitting the binomial distribution or finding out the expected frequencies as per binomial distribution. This is the method. So, we have completed 18 problems on binomial distribution. So before that, I have explained you what is binomial distribution, what is the formula, what are the characteristic features, what are the assumptions we have discussed. So hope you understood my lecture. So if you are satisfied, please like my video, share it and subscribe my channel. Okay, in the next video, I'll start the new topic, Poisson distribution.